Welcome to SanfordFlipMath, the home edition. This is PreCalculus. We're starting in section 1.1. This is the Larson book that we're working through. So we're going to get right to it. This particular section is absolutely a review section. We're going to get your toe in the water. It's going to feel like it moves fast, but that's really just because you already know all this. Well, that's a lovely thought anyway. So just a reminder, we're going to talk about lines, linear equations, graphs of lines, things like that. So just a reminder that a line has to be straight. How do you define straight? Not curved. Well, how do you define curved? Not straight. Yeah. So it's one of those, we kind of all know what it means, but in terms of how to specifically define it, it's very difficult. It's one of those undefinable things. In terms of identifying whether something is linear or line, it has to have a constant slope, whatever that is. We'll talk about that in just a second. Or in other words, a constant rate of change. The ratio of change in y to change in x has to be consistent. In order to locate a line, you need to have 2 points. Now, you can start with a point and use the slope, again, which we will talk about again. You can start with a point and use the slope to locate a second point, and then we'll go from there, and then you've located basically the entire line. Slope, as you are probably aware, or I hope you're aware, is often referred to as rise over run. It is a ratio of the change in y over the change in x. The formula is typically written this way, and remember that these are not exponents, these are subscripts. So they are below the variable, just to represent this is the second y minus the first y, the second x minus the first x. And honestly, it doesn't really matter just as long as you are consistent. These two guys have to come from the same ordered pair, and these two guys have to come from the same ordered pair. Since slope is often sometimes referred to as steepness, right? Because that's really what it's about. It's a numerical representation of how steep a line is. And some other things to note, if your change in y is positive and your change in x is positive, then the line's going to be going up. So positive slope. And if your change in y is negative and your change in x is positive, then you're going to have a negative slope. Or you could even have a change in y that's positive and a change in x that's negative. So if your rise or run is negative, but not both, then it'll be a negative slope. So if it's going down like this from left to right, negative slope, going up. I'm hoping all of this is very familiar. Parallel means you have lines that are going in the same direction. And since direction and steepness are basically the same idea, parallel lines have the same steepness, or in other words, the same slope. It's not slope, that's slope. Perpendicular lines are lines that intersect, forming a right angle or a 90-degree angle. Now, the problem is, what's that mean for slopes? Well, it turns out they need to be opposite and reciprocal. Now, again, if this was an Algebra 1 class, we would spend a lot of time doing graphs, drawing angles, and measuring and showing how this actually works. But they have to be both opposite and reciprocal. And again, I'm just trying to remind you of these things. So like, for instance, if I have a slope of 1, then the slope of a perpendicular line has to be the reciprocal of 1, which is also 1, and it has to be opposite, so -1. If I have a slope of 3/5, then the line that's perpendicular to that, okay, that's the perpendicular symbol, would be the opposite and reciprocal. So I have to both flip it and change the sign. All right, one more just for kicks. If I have a slope of -2, then the slope of a perpendicular line has to be the reciprocal and opposite. Well, the opposite of that negative is back to positive. Okay, and there are a number of forms of the equation of a line. Most of you start out learning slope-intercept form, which is probably everybody's favorite. It's not technically my favorite when you're writing a line, the equation of a line. The nice thing about it is, if you know the y-intercept and you know the slope, then you can write the equation of a line. If you have the equation of the line in this form, it's pretty easy to graph because you locate the y-intercept, a point, and then use the slope, the number in front of x, to locate a second point you can graph. Okay, this second one is called point slope. It's cleverly called point slope because you use any point and the slope. So here's the slope, but this x and this y are the point. Okay, so super easy to write, which is why it is actually my favorite. So like for instance, if I had 1, 3, and the slope was -7, it's crazy easy to write this. I just say y minus the y value equals -7 times x minus the x value, and boom, I'm done. That is the equation of a line. I don't need to do anything else to it if it doesn't specify a form. Okay, so that's point slope form. And you can graph from this form. I can pull the point from here and say, oh, that's 1, 3, and the slope is -7. So I could go to a graph and go to 1, 3, and -7. So down 7 over 1. Hey, look at that. I can graph from that form also. This guy is standard form, typically not anyone's favorite for graphing. It's actually not too bad if you use intercepts. So like if you substitute a 0 for x, then you can solve for y. Substitute a 0 for y, you can solve for x. And that's a sneaky way to do that. This next one's called general form. It's very, very similar to standard form. It's just the constants on the other side. Okay, also worth noting for these two, general form and standard form, you're not allowed to have any fractions in here. So if it starts out having fractions, you have to multiply through by a common denominator to clear them out. You're also not allowed to start with a negative in the front. So they have some specific rules. We're not going to use these a lot. They'll come up, but not a lot. Much more useful to focus in on these. This is the equation of a vertical line. And the easiest way to keep it straight is if x is a number, like this could be x equals 3, then that means every point on this line has an x value of 3. So if I were to graph that, here's 3, here's 3, 3, 3, 3. All these points have an x value of 3. Hey, look, it's a vertical line. And similarly, this one would be a horizontal line. Y equals a number. So like y equals 2. So, you know, here's y equals 2, but here's y equals 2 also. All these places, all these points have y values of 2. So just a reminder that equations of lines typically have both x and y in them. And the idea is that any ordered pair that's actually on that line is a solution. Any ordered pair that's actually on that line makes the equation true. So if you substituted both x value and a y value into the equation, it would have to be a true equation. You know, it would have to come out like 7 equals 7 if you simplify everything. All right, so that's all the background. We're going to do just a little bit of examples. And again, if it feels like we're moving fast, you know, keep in mind that, you know, I know you're probably new to the whole SanfordFlipMath thing, the whole video thing, but feel very free to pause, rewind. Yes, you need to take notes just to show that you've seen the video. But the idea here is that, you know, for this specific section, it's all review. So, I mean, you've seen this for years. Pre-algebra, algebra 1, algebra 2, and yet again in pre-calc. We're not going to spend our life on this because this is just to get your toe in the water so we can get things going here. All right, so here I have a lovely point and a graph. We're going to do some examples. A point and a slope. That's what you need to know in order to graph a line. And again, the idea is you start with a point, and then you can use the slope to get yourself another point. I don't need you to have graph paper. I know some of you are going to want graph paper. You're welcome to bring graph paper, maybe have a notebook of graph paper if you wish, or just a few extra sheets in there. I won't be supplying graph paper because honestly, I'm okay if we just sketch things. So it needs to be easy enough to follow. Now, I'm always going to assume on a graph that you're numbering by ones unless you put some different numbers on there. So it's not, I don't need you to write a 1 and a 2 here so I know you're counting by ones. I'm going to assume you can, obviously, but I'm going to assume you're numbering by ones unless you number differently. So like if you wanted this to be 5, then you have to put a 5 there. Okay, if you don't put a scale, I'm assuming it's by ones. Okay, all right, so here I'm locating the point 1, 5. Now remember slope, which is cleverly notated as m. who knows why it's M? I don't know either. It's quite annoying, actually. So this is rise, this is run. So rise is up and down. So I'm going to rise from this point. You got to be working from a point on the graph. I'm going to rise 1, 2, but I'm going down because it was negative. And I'm going to run 1, 2, 3. All right, so I'm going to notice I did not get out a ruler. I'm just doing my best to do a nice straight line. Now, yeah, I do have some practice. Again, if you know, some of my students are very, very particular, and I get that. So if you are going to use a ruler for everything, that is awesome. I will love you. I will just be very excited about it, but I'm not going to require you to do that. Okay, also worth noting, we could have started at this point because that was the only point we knew. And we could have thought of that negative as with the bottom and not with the top. It just can't be with both. So then I could have actually risen 1, 2 and gone to the left or backwards 1, 2, 3. And notice that still puts me on the same line because that works. Now, when there's a negative though, it doesn't make both of them negative. It's either one or the other. Okay, so if I would have gone down 2 and backwards 3, that's clearly a different line. Okay, so that would be a problem. All right, example 020, so Spanishy. So I'm going to start again with a point. Happens to be the same point because I'm so not creative. No, slope is undefined. What's that mean? That refers back to my crazy T-shirt that I'm wearing. Right, let's take a minute. Yep, it's all fun and games until somebody divides by 0. All right, so undefined comes from dividing by 0. So that means this was a slope that was something over 0. And honestly, it doesn't matter what. It could have been 2 over 0. It could have been 553.8 over 0. We don't care. Okay, so something over 0. So the run was 0. So if I go from this point and run nothing, so left and right, I'm not going anywhere. I can do a rise of anything I want. It really doesn't matter. This is a vertical line. Okay, so the equation of this line would actually be x equals 1. That's the vertical line equation. Remember that x equals something. Okay, and we wrote that down a minute ago. X equals some number. Okay. Okay. Also worth noting, if I wanted to pop back, this would be y minus 5 equals the slope times x minus 1 if I do point slope form. Okay. Holy cows, I just did number 3. Who knew? Right? So remember, point slope, well, I did half of it. Point slope form is y minus a y value equals slope times x minus an x value. So y minus 5 equals the slope, x minus the x value. Now, I'm asking for this in both point slope form and in slope intercept form. Now, if you have two plans, you have two ways we can get to slope intercept form. One way would be to start with point slope form, and then we could convert it. So for slope intercept form, we want it y equals mx plus b. So we want the slope and the x separate from the y-intercept, a constant, and we need y by itself. So I could just take this guy and distribute, and then add 5 to both sides. Now, oops, sorry, I didn't know it was off screen. I don't know about you, but I'm really not that excited about mixed numbers. There's nothing wrong with them. They're just not so cute. So I'm going to write this as 17 over 3. Okay. And if you wanted to, you could write this as 5.667 if you wish, or 5.6 with a line over it. In this class, regardless of what the book says, regardless of other stuff, we're going to go 3 decimal places if we're using decimals that need to be rounded. And I will be okay if you round it or truncate it. Now, remember, this is actually more than 3 decimal places. This is an infinite number of decimal places because this is saying they keep going. Please do not, though, write this. Some people will write this, right? So they'll say, oh, look, these 6s keep going forever. And then after forever, there's a 7. Yeah, there's no such thing as after forever or after an infinity. So you might see a 7 on your calculator because that's your calculator rounding. So let's not do that. Okay. All right. So we're going to do one more, and then we'll be done with this video. So again, you need a slope. In order to write the equation of a line, you need a slope and a point. Well, I see the point. I need a slope. And that's what this information is going to give us. Now, sometimes slope, you're going to actually have to find the slope with the slope formula. I'm not trying to do an example of every single thing in the universe here. I'm trying to give you an overview. Again, this should be review. So we're just trying to fill in some quick blanks and get your brain back engaged in math. Okay, so perpendicular to this. Well, this is already in point slope form. So this guy right here is the slope. If I want the slope of the perpendicular line though, as we mentioned before, we need to do both the opposite. So I need to make it negative because it's already positive, and the reciprocal. So I also have to flip it. So 2/3. Okay, so here we go. Y minus the y value equals slope times x minus the x value. And this is point slope form. So again, this is why I love point slope form, because it's just crazy easy. Now, last time when we did slope intercept form, we converted point slope form. Well, I'm going to do it the other way. I'm going to do it like back in the day when you didn't know point slope form. So I'm going to write down slope intercept form with the slope, but I don't know the y-intercept. So to get the y-intercept, this is just another approach. To get the y-intercept, I'm going to substitute an x and a y value that I know that are supposed to make this work. Hey, that's those guys. So I'm going to say 5 equals negative 2/3 times that x value plus b. All right, so then we're going to simplify this. That's negative 2. I'm going to add 2 to both sides. Now, this is pre-calculus. This is big girl, big boy rules. Okay. Do I need you to show work? Absolutely. Do I need you to show every little baby step, like that little +2 right there? No. Some of you need to anyway, but I am not going to be a stickler about every tiny little baby step. Okay, so you're going to have to monitor what you need to do. If you need to show every little baby step because you find that you make mistakes by not writing stuff down, then slow your roll and show every little baby step. But if you're like, okay, adding 2, yeah, whatever. I mean, the important steps, yeah, you know, when you're doing something that you're introducing an idea that needs to be tracked, yeah, absolutely show that. But again, little foo-foo baby steps, and we might not agree on what a baby step is, so we might have to clarify that as we go. But that's all right. We'll figure that out. All right. Well, this was the first Sanford Flip Math of the year. Welcome to the whole flipping the classroom concept. So the plan in class will be for us to do book work together. Typically, that's what's going to happen is homework will be a video, book work in class. And the great thing about it is what we used to call homework would be done in class. And then if you get stuck on something, you can say, yo, what'd you do with number 7? Oh, and you learn from each other. Or if neither of you know, you go, yo, Sanford, can you come over here and help me with that, please? So, all right, well, much love to you. It'll be awesome to chat about this. And thanks for getting your toe in the water with me. And we'll see each other again. Sanford Flip Math out. Bye.